In this video, we're going to be discussing how to simplify expressions that have variables. So we've talked about simplifying expressions that didn't have variables, so they all had like terms. But in this case, we need to make sure that what are in the expressions can be combined. So like terms, well, are things that are the same. And what you look for is whether your variables are exactly the same. So you could have the same variables in a couple of terms, but if there's something else connected to it, another variable, they would not be able to be combined. And so I will show you that as we go through these. All right, so for the first one, I have 4x minus 2x. So the way that I look at these is once I know that I have a like term, which I do here because I have a single x in both of these, I go ahead and disregard that for a minute, and I look at what's called the coefficient, which is the number in front of the variable, and I go ahead and do that calculation. So here I have 4 minus 2, which is 2, and then I have that x. So really what's happening is you have, visualize a pile of 4 x's on the left-hand side, and then you're taking 2 of those x's away, and so you're left with 2x. All right, so let's move to the next one. So again, I look and notice that each of the terms have a single x in them. So that tells me I can combine all of them. Now I'm going to go ahead and look at the coefficients. Now there isn't a coefficient or a visible number in front of that x, but there is a negative sign. So whether it's a negative or a positive, if you don't see a number, it means that there's an invisible 1. So I'm doing negative x plus 5x. So that's negative 8 plus 5. I've got more negatives than I do positives. I go ahead and subtract, right? So basically 8 minus 5. So I get negative 3x minus 1x. Once I've done that, I'm going to go ahead and combine again. So negative 3 minus 1, I move 1 further to the left. So now my answer is negative 4x. And that is my final answer. Okay, so a couple vocabulary there, right? Coefficient, or that's the main vocabulary. Coefficient, the number in front of a variable. Term is anything separated by an addition or subtraction sign. So the first problem has 2 terms. B has 3 terms, and so forth. And then if you don't see a number in front of the variable, it means that there's a 1. All right, let's move to the next one. So here we have B's in each of them, but notice that the last one also has an R. As soon as I see that, I know that that last term cannot be combined with the first 2 because they're no longer like terms. All right, so here I have, there's that invisible 1 again. So I have 1b plus 3b, which is 4b, minus 4br. And again, those are not like terms, so I cannot combine them any further. So that is your final answer. All right, let's move to the next one, D. So notice they're getting bigger and bigger, right? C had 3 terms, D has 4 terms, but it doesn't change the process. All right, now this is the first time that we've seen an exponent on a variable. So if the variable and the exponent are the same, it means that they're like terms, okay? So I can go ahead and combine the negative 6x squared plus 10x squared. If it's easier, you can actually rewrite it using the commutative property of addition. So I'm just going to change the order and put the like terms together. Plus 10x squared plus 7 minus 10. And now I go ahead and combine these. Well, this is the same as 10x squared minus 6x squared, which gives me 4x squared. Okay, and then I have plus 7 minus 10, or actually I'm not going to skip that step. I'll be very thorough. So I just rewrote what was left. Now my 4x squared is unchanged, and I go ahead and do my 7 minus 10, which is negative 3. So that is your final answer. Okay, now we're going to move to the distributive property, which we were introduced to that as if you have parentheses with something on the outside being multiplied, you can do that multiplication where you take what's on the outside and multiply each thing on the inside. Now, when we were introduced to it, we could simplify what was on the inside of the parentheses. In this case, we can't because they're not like terms. So all we can do is go ahead and multiply through that 5 to each term on the inside. So you have to use the distributive property if what's inside the parentheses cannot be combined. All right, so as a reminder, this is the same as 5 times x and then 5 times negative 1. So I'm going to show that intermittent step, okay? And then we have minus 1 times 5, right? So each of the terms has been multiplied by the 5. And now I go ahead and combine those, and I get 5x minus 5, which I cannot combine because they are not like terms. Okay, let's go to B. So here I have the same thing, negative 2 times 3y, negative 2 times 4. So that negative has to be multiplied through by each of the things on the inside of the parentheses. Remember, if you multiply by a negative, right, it means that your signs are all going to switch. So we have negative 2 times 3y, which is negative 6y. Same thing as with adding and subtracting. You just look at those coefficients, do the calculation, and then the variable kind of goes along for the ride. All right, and then I have negative 2 times positive 4, which is negative 8. So negative 6y minus 8 is your final answer because, again, they're not like terms. You cannot combine them. All right, so for C, what we need to look at, even though I haven't mentioned it here, we still are using order of operations, okay? So I'm going to write my GEMDAS, which I always recommend that people do. Okay, and so we need to see, well, is there grouping? Yeah, there are parentheses, but I can't actually combine what's in there. So grouping doesn't apply. Exponents I don't have, but I do have multiplication because this number right here is sitting right next to the parenthesis. So you have to do the multiplication first. Now this is the same as multiplying through by a negative 3. So the sign in front of the number that's being multiplied gets applied during the multiplication. So I get negative 3 times x. So I'm going to go ahead and just write the 17 because that's untouched. Minus 3 times x is minus 3x. And then negative 3 times negative 4 is plus 12. All right, so now I need to look for my like terms. And notice I have 17 and 12 that are like terms. 17 plus 12 is 29 minus 3x. And that is your final answer. All right, so we're just getting, more terms, more steps that we need to do, but we still follow exactly the same steps. And it all goes back to order of operations. So I don't have grouping that I can do. I have exponents, but not with anything I can do calculations of. But again, I do have multiplication. So I have to do my multiplication first. So I'm going to write my 3, and then negative 5 times x cubed is negative 5x cubed. Negative 5 times positive 2 is negative 10, and then minus 10x cubed. All right, so notice in all of these, the first step has been that we've gotten rid of our parentheses by using distribution. Most of the time, that is going to be the case, is that distribution happens first. All right, so now I'm ready to combine like terms. So I notice here I have a 3 and a negative 10. So this is 3 minus 10, which is negative 7. Right, so that takes care of those. And the way I'm crossing these off is actually how I tend to do these things when I'm doing keys or just checking problems that I've written. It really helps me stay organized. All right, and then here I have negative 5x cubed minus 10x cubed. So negative 5 minus 10 gives me negative 15. And then again, that x cubed is unchanged. All right, so I recommend pausing and going ahead and trying E here, and then go ahead and restart the video and see how you do. Okay, so grouping, I do have a grouping symbol, but again, I cannot combine what's in there, right? Because they aren't like terms. So I need to go straight to my distribution, which is my multiplication. So I distribute 7 throughout. I get 7x squared. 7 times negative 5 is negative 35. Negative 4 times x squared. So again, that negative just travels with that number. So I have negative 4x squared. And then negative 4 times negative 2, which is positive 8. Now I need to look again for like terms. So I see an x squared here, another x squared here. Again, that sign travels with the coefficient of the x squared. So I get 7 minus 4, which is 3x squared. And then I have negative 35 plus 8. So I usually recommend, if the signs are different, go ahead and just do the larger number minus the smaller, which in this case would give you 27. So 35 minus 8 gives you 27, but then you have more negatives, right? Negative 35, so your answer has to be negative. So in this case, it's negative 27. And just to kind of draw out what I just said, so the way I figured that out was I said, okay, well, what if 35 were positive? And then I needed to take away the 8. So basically I'm figuring out the difference. That's 27. But then I had more negatives than I did positives. So I knew that my final answer had to be negative. So that's one way to think about it. You can also use a number line, right? So there are a few different strategies.